two-sum, threesome. There actually is a threesome algorithm. I haven't messed it with it, but two-sum, cool algorithm to know, and let's get into it. Thanks for watching. Okay, so la-di-da, la-di-do. How does this work? Let me show you. So array is the first, such a dork. Array is the first parameter, num is the second parameter. So we're passing in an array, and then we're passing in a number. And what we're looking at is each element in the array, and we're trying to find its counterpart that adds up to 12. And if we find it, we're going to stick it into its own array and then pass an array of arrays. So it'd be like this. And so like 8 and 4 add up to 12, right? 8 and 4. That would be one array. And then we'd have something along the lines of 9 and 3, right? That adds up to 12 also. So it'd be something like that is what we're looking for. Alright, so let's do it. Let's do this thing. So you could like loop through the array and look at each element in a number of different for loops, but I'm just going to do the classic one. Maybe future videos I'll do ES6 versions. But here it's fairly straightforward. So let I equals 0. I is less than array.length and I plus plus. Now we'll get the current number. Is array at I, and we need a place to stick the current number. So I'm thinking we'll set up a couple of arrays, empty arrays. One will be the pair arrays to stick the two numbers that add up to 12, and another array for like keeping track of all the numbers. So the hash will be the hash table to keep track of the numbers, and then we'll have a pairs array to stick the pairs in. And so let's just do hash.push the current number, return hash outside of the for loop, right? And let's see what that looks like. Okay, so that's basically what this is. 6345819. The next thing we have to do is we've got to set a condition. First we need the counterpart. The counterpart is to determine the current num, which is 12, minus the current number. Okay, so 12 minus whatever the current number is, which is one of these numbers in here. And so we're going to put the counterpart in here just so you can see what that looks like. See, so these are different numbers, like 11 is not here, right? So that wouldn't be included. We don't have a 7. Alright, so we're going to put the current number into the hash table. We're going to say if array.index of the current the counterpart is greater than -1. So we're going to say, hey array, do you have the counterpart in your index? If you do, return it. And if you don't, it's -1, right? That's what an array will return when you ask it if it has this element. And the way it looks it up is through the index. So using the index of command here, or method, is a way of asking an array if if they have an element. And when it does not have an element, it'll return -1. But we're saying if your return value is greater than -1, that means you have this counterpart element. So in which case we do pairs dot push, and we're going to set up that array, the current number and its counterpart, and then we're going to return the pairs array. If you run it, you'll see it. It's got 6, 6, and then 12, 12, and it all looks good. All these numbers add up to 12 in each element. But you seem like duplicates. We got 6, 6. We got 3, 9. Why is it doing that? Oh, because we're not asking the right question. We got to ask the hash table instead of the array table. Pushing all the current numbers in there. And when we do that, we get a more accurate depiction without the excess fluff. Why is that? Because we're iterating through the array each time, and we're passing through the hash. And we're asking this question of the current hash being iterated through. Let's just look at something just for fun and games and giggles, because I like giggles and games. Console.log, right? Hash. Oh, he saved every one of us. Look, watch. See how the hash kind of grows? Versus the array, which stays constant. Array. Okay. Like the array never changes, but the hash table kind of grows as you iterate it through. And so each time this condition is met with the counterpart, it's pushing, that pair into it. And once the condition's met, it doesn't essentially do this valuation each and every time. It doesn't start over. It just skips over it, so you don't have those duplicates. Once this condition is met, it's not just going to have a duplicate in there. Does that make sense? You see that, people? And if we ask the array, hooray! That's why we don't just pass the array and we pass the hash. We create the empty hash table and push the numbers in there, because that kind of grows over time. But if you just access the array, you're going to get each time a counterpart is present in this array, it's just going to find all the duplicate instances of it, because it's starting from the beginning of the array and then goes through the entire array. That's why you got 6, 6 here. Does that make sense? Am I making sense? I hope so. Anyway, I hope I didn't bore you to death on that. Look at that. Okay, so that's TwoSum. It's a cool algorithm. It's a happy algorithm. I'm happy. I hope you're happy. Happy holidays, and thanks for watching.